So we know there are some really big things that are out there flying around. There are some things out here so big that they could hit Earth. They could actually punch their way through the atmosphere, hit the ocean, punch their way through the ocean, hit the ocean floor, go through the ocean floor into the upper mantle before the top of the asteroid is even done entering the atmosphere. So there are some really big things flying around out there, and it's only a matter of time until something like this hits Earth. And evidence is that it's hit Earth before. Okay, things of this size must have hit Earth in the distant past. And so what would that do? Well, that would be, for example, in this like catastrophic sort of category right here, that would truly devastate things. Because what would happen? Well, you hit an impact of that size and you scar the surface of the earth. You would end up with thousands of years of volcanic activity, not just volcanoes, but major volcanoes that would be spewing all kind of chemicals in the atmosphere. The impact itself would throw stuff into the atmosphere. You would alter the climate of the planet significantly for a very long time. This would have enormous pressure on life forms. All right, so what could happen? Well, I ran to this little graphic right here, this little cartoon, and it's interesting because we think this is kind of what happened at the end of the age of the dinosaurs. Uh, right near a village called Chicxulub in the Yucatan, oil companies found what we call an astrobleem. Now, astrobleem is a fancy word right here, which is this scar on the surface of the earth due to an impact. So after erosion has covered everything up, and then other kind of geologic activity has buried it and hidden it, there's still evidence of a big impact there. And this evidence is an astrobleem. The crater near Odessa is barely even visible, so it's sometimes referred to an astrobleem as well because erosion has just about covered it all up. Now, the interesting thing is that this Chicxulub astrobleem dates back to about 65 million years ago. This is when the dinosaurs died off. So that's very interesting. Now, what would happen from an impact this size? An impact of this size, because we can actually look and see how big the crater is, and it is absolutely enormous here, how big this thing is, hundreds of miles across. An asteroid impact of this size would actually shatter the crust. You would actually vaporize a big chunk of water vapor, blow it into the atmosphere. The original hypothesis they had was the impact would throw so much dust in the atmosphere that it would block out the sun for several years, the plants would die, and all the big animals that ate the plants would die, and the animals that ate the big animals that ate the plants would die, and only small things would survive. That's very tame compared to what we now think would happen. What we now think would happen is this thing would come in, and yes, it would throw so much stuff into the atmosphere that it would in fact blot out the sun for a while, and a lot of plants would die. Okay, so, and then you have starvation and other sort of things going on. But it does way more than that. It would vaporize vast amounts of water, throw it into the atmosphere, and it would rain for weeks and weeks and weeks across the entire planet. You would get mud, silt, floods on a global scale all over the place. And so that would also pressure things. You would also throw an enormous amount of material, molten stuff, into the atmosphere, falling back down as secondary meteorites, flaming molten blobs of rock falling everywhere on Earth. That would secondarily create fires that would ravage the entire planet. So you have global fires happening. Then it gets worse than that. You've actually disrupted the ozone and the stratosphere. Massive amounts of ultraviolet would get through. That would create massive, horrible burns on any animals on the surface of the earth. Then it gets even worse. it would get so hot you would actually create fire tornadoes, supersonic tornadoes spinning around of burning nitrogen gas. And so you would actually burn the air. The air would catch on fire. You'd burn the nitrogen all the way up into the stratosphere, these giant whirling tornadoes, and then it would be raining nitric acid across the entire planet. Okay, then it gets even worse than that. Okay, you've cracked the crust of the Earth, and so now you get thousands of years of massive volcanic activity, spewing sulfurous gases out, spewing other sort of gases out, spewing dust and particles out. You alter the climate of the entire planet. Parts of the planet are going to massively cool down from all the dust blocking the atmosphere. Then it's going to massively warm up because of all the greenhouse gases you reduce. Then it's going to cool down again, then warm up. It's going to be this massive sort of climatic disruption. And a lot of things are going to die. Pretty much anything that can't adapt to these massive things would change. And then again, that's most of the big things. So it's not that the asteroid hit and all the dinosaurs fell over dead. You know, it's rather that you know, a bunch of them fell over dead, but then you've altered the planet to such an extent that you've now created an environment that most things can't live in, and so you have a massive extinction event. Geologically, the rocks here are the boundary between what we call the Cretaceous and the Tertiary, the KT boundary. K for Cretaceous, even though Cretaceous starts with a C because we're using C for another layer. But the KT boundary all around the Earth, you know, same sort of thing. You know, in the Cretaceous you got dinosaurs, in the Tertiary you don't. And you have different kinds of animals, different kind of plants in some cases. And so you have this massive sort of die-off that happened. And you also frequently have this, between the Cretaceous and Tertiary, indications that something bad happened. You've got silt and mud everywhere from like global flooding, and then you've also got mixed in a lot of soot and acid. And now here's and of course all that you expect from an impact like this. And you also have deposits in here of iridium. Iridium is a rare earth element, so named because it's rare on Earth. But iridium is fairly common in meteorites. So this suggests that about this time you had a meteorite impact. For a long time, there's been a huge debate on what killed off the dinosaurs. You know, was it the impact, or was it, you know, some other factor? Was it a supervolcano? A supervolcano went off about the same time too, but then given the size of an impact, it's no great stretch that the shock of that could actually possibly trigger a supervolcano. So there's a variety of possibilities here, you know, that all relate to this impact. More recent studies indicate that the other ideas they had don't quite seem to hold. It looks like that this impact was in fact a full extinction level event and triggered mass extinctions across the Earth. Turns out the KT event from 65 million years ago was not the biggest mass extinction event. There have been other mass extinction events even bigger. Life is very precarious on this planet, you know, with the sky falling the way that it is. As I said, really big impacts like this, slamming into the ground, you know, even before the top of it enters the atmosphere, that is bad. That would have an utterly devastating impact on Earth. The climate globally. Not just at the blast, not just all those other things, but you have now altered the climate of the entire planet for millennia. And so that is something that's very difficult to recover from. A number of years ago in Torino, Italy, they actually assessed a scale, created a scale here to rank how bad an impactor might be. So in other words, if you see an asteroid out there, you give it a terrenal impact scale as to how likely, it is to impact and how bad the impact would be. So you would say, if the impact is not very likely, it's likely to get a low number unless that not very likely corresponds to like wiping us all out. It probably won't hit, but if it did, it kills everybody. That might rank a 1 or 2. Okay, the more likely it is, the bigger the number. So an absolutely global impact that's pretty certainly going to happen, we call a 10. That's like we're all going to die and we're almost positive. That's a 10. Okay, whereas we're pretty sure that it's going to miss us, and if it does miss us, it's not all that bad. That's going to be like a 0. And so now you have kind of the range here of what this terrenal scale would be. Since they implemented the scale, they've only gone up to levels 1 or 2 in this.